Now, you know I said that the structure of periodic table, we have what? We have groups, abi?
Yes.
And we have what? And we have periods, right? The elements that are arranged in groups, they are the elements that are arranged in what? In a vertical what? Order, exactly. Vertical line. Are you with me?
Yes, sir.
Now, when I took you to the periodic table there, I showed you the first group being what? Group 1, abi? Group 1. Group 1 can also be called group IA, abi?
Yes.
But if you tell me group 1, I'm alright with that. Are you people with me?
Yes, sir.
Now, you don't need to cram anything in chemistry. You just need to know the reason why it is like that. Now, the reason why we call the group 1 element as group 1 is because of what we call their valence electron. It's because of what we call their what?
Valence electron.
So group 1 elements, they have how many valence electron? 1. Now I will show you now. Valence electron is 1. And how do you now know that they have 1 valence electron? Just write them out. You know I told you that what? Starting from hydrogen, abi? Although I said hydrogen is what? Good. Just know it like that. Hydrogen does not really have a particular group. But I will tell you why it is still part of the group 1. Please listen very well, okay? I will not start with hydrogen. I will start with the second one, which is what? Lithium. Which is what? Lithium. Group is vertical. Good. So the group 1 element, hydrogen, I will separate. Abi? We now go to the next one. Lithium. Sodium is the next one. So we stop there. We stop there. I will show you. You are the one that will now tell me the rest after I've shown you this one. Now let's start with the lithium. Lithium falls on position what? 1, 2, 3. Position 3. God bless you. If you want to know the position, just count. But yeah, what's the first element in the periodic table? So followed by. That's position what? Position 3. Now that position it falls is what we call the atomic number. It's what we call the what?
Atomic number.
It's also called the what? Proton number. So that 3 is the atomic number of lithium, and it's also the what? Proton number of lithium. Do you also know that because lithium does not carry any charge, because lithium does not what? Carry any charge, that means that what? Because it does not carry any charge, that means that 3 is also the what? The electron number of what? Of lithium. That 3 now, revise with me. That 3 now, it is how many number of what? Is how many number of lithium? Like 3 numbers, abi? The first number is that what? It is the what? It is the atomic number, abi? Because that is the position of lithium. The second is that what? It is the what?
Proton number.
The third is that what? It does not carry any electric charge. That means that it is also the electron number of lithium. 3. Atomic number is 3, proton number is 3, electron number is 3. But if it is carrying a charge, plus or minus, you are going to increase or what? Or decrease. When we get there, I will show you, okay? Good. Now let's continue with it. We want to know why they are having what? Valence electron of what? Of 1. Please pay attention. Now, there is a particular electronic configuration that we call the shell notation electronic configuration. The what? The shell notation electronic configuration. Now, what is the meaning of shell notation electronic configuration? First, what is the meaning of electronic configuration? Electronic configuration means that we want to arrange electrons in their what? In their shell. We want to do what? Arrange electrons in their shell. That is the meaning of electronic configuration. There are different types of electronic configuration. But the one we want to use now is called what? Shell notation. It's called what?
Shell notation.
Shell notation. You see, in chemistry, shell can also be called energy levels. Shell can also be called what? Energy levels. We have different kind of shell, starting from K shell, L shell, M shell, N shell, O, and so on and so forth. These different energy level or shell, they have different amount of electron that they can contain. They have different what? Amount of electron they can contain. For the K shell, it can contain maximum of 2 electrons. Now, how did I know? It is very simple. There is a formula called 2L to the power what? 2. There is a formula to know the amount of electron it can contain. Yes. This N is different from this N. Are you getting it? This N here means principal quantum number. Means what?
Principal quantum number.
Principal quantum number. Yes, quantum number. That is what the small letter n means. Why this n means what?
Shell.
Shell. It's an energy level of shell. Okay. Now, for each shell, the principal quantum number increase or it is different. For the K shell, it is 1. For the L shell, it is what? 2. For the M, it is what?
5.
This is 4, this is 5, and so on and so forth like that. If it continues like that, okay? Now, for us to now know if it is really 2, put the formula here. 2n raised to the power what? 2, abi? Now, put 2 here. This is the 2 here, abi? This n, what does it mean here? Put the 1 here. Raised to the power what? And what is 1 raised to the power 2? 1 times 1. 1 raised to the power 2 is what? 1 times 1 raised to the power 3 is what?
1 times 1 times 1 times 1.
Very good. 1 multiplied by itself, the number of what? The number of power. So this is 1 times 1. And what is 1 times 1? 1. So we now have 2 times what? 1. Because bracket means 1, abi? What times, abi? So we now have 2 times 1, which is what? 2. That is why K shell is what? 2. Let's check the number for L shell. See, use the formula 2. What is n? 2. Put the 2 here. Raised to the power what? 2. You first sort this one, abi? From God mass. 2 raised to the power 2 is what? 2 times 2, abi? 4. That we now have 2 times what? 4, which is what? 8. So the maximum this one can contain is what? 8. Let's do the next one. Look at the board. Look at the board. 2. 3 raised to the power. Very good. 3 raised to the power 2 is what? 9. 3 raised to the power 2 is 9. It's 3 times 3, not 3 times 2. Okay? Please pay attention. So we now have 2 times 9 is what? Now this one is going to be your classwork. Wait, leave it. I want to show you something first. You'll do it later. Now, we already know the maximum number of electrons each of them can contain. Am I right?
Yes.
Very good. And the next thing to know is how it is useful here. Is how it is what? Useful. Now come back here. If you want to do the shell notation electronic configuration, you already know that lithium has how many total electrons? 3. The first shell will contain how many electrons? 2. You write it. You know it is total is 3, abi? Out of 3, you have written 2. How many is remaining? 1. You put the 1 here. That's what we call shell notation electronic configuration. I will do the next one so you know, you understand it better. Now let's go to the next one. If you want to know the number of electrons, if you want to write electronic configuration, you need to know the number of electrons, abi. We know this number of electrons, that is why we did it, abi. Now let's do the one for sodium. If you want to know the number of electrons, just know the position that what? That sodium is. Am I right?
Yes, sir.
If I don't follow you, just know the what? The position that sodium is. To know the position that sodium is, just count from hydrogen, abi. Oh yeah, let's count. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That's number what? 10, abi. The next one is what? Sodium. Sodium is number what? 11. That means the atomic number of sodium is what? 11. The proton number of sodium is what? 11. Now, to know the electron number, check maybe it has a charge. Does it have a charge? No. That means the electron number is also what? 11. Very simple. Now, the first shell, what we enter? 2. Abi? Yes. See now, is it not 2? Yes. The next shell, what we enter? Is 1. Out of 10, out of 11, this is 10, abi? Yes. It remains how many? 1. Put the 1 here. Can you see it now? This is the reason. This is the reason why what? Why the both of them are in group 1 together. The remaining one too, like potassium, which one again? Rubidium up to francium. All of them they are in group 1. Why? Because they have one what? They have what? What? Valence electron. Now your classwork now is to do the next one, potassium. Just do only potassium. But before you do the potassium, don't forget that you are going to do these shells too, abi. So do these shells first and then do the one for potassium and show me the reason why it is in group 1.